think. And we're live. All right. Good evening or good morning, everyone. Welcome to the Science Week edition of the Astronomy on Tap in Cambridge. We once again couldn't invite you to a pub, so we came to your screen instead. Grab your favorite pint or a cup of tea and enjoy our fantastic talk on chasing water on Mars today. Today with us is a very special speaker who will tell us a little bit about herself in a second. Debarati, please give us a couple of words about who you are and what you do.
Awesome. Hi everyone in their homes. I'm sorry I couldn't meet you in person. I'm Debarati Das. I'm a graduate student at McGill University in Canada, Montreal. It is slowly starting to warm up and I'm getting really excited. I hope your weathers are similar and you're not depressed because of winter anymore. I'll give you more details about my research, who I work with in my slideshow.
Thanks a lot, Debarati. All right, Johnny, since you're to the right of me on Zoom, would you mind saying a couple of words about yourself?
Yeah, sure. I'm Johnny. I'm a second year PhD student at the Institute of Astronomy here in Cambridge. I work on terrestrial planets like Earth and Mars and Venus, their atmospheres and also their interiors as well.
Thank you. Chloe, the floor is yours.
Hi, I'm Chloe. I'm a first year PhD student at the Institute of Astronomy in Cambridge, and I specialise in galactic archaeology. So basically looking for fossils in the Milky Way halo, and then we can infer more about how the Milky Way was formed.
Thank you. Annabelle?
Hi everyone, I am a second year PhD student also at Cambridge. I study galaxy clusters and also supermassive black holes at their center. I'm usually in Cambridge, but because of pandemic, I'm also situated in Montreal, Canada. So we're two at the same place.
All right, and quickly to your technical MC. My name is Asha, and I study galaxies as a third-year PhD student at Cambridge as well. Primarily, I focus on the influence of supermassive black holes on galactic evolution, and today I am not in Cambridge either, actually. I happen to be in Los Alamos, New Mexico, United States, so fairly close to your time zones, ladies. So a fairly location-wise international crowd today. Since it's April Fool's, April 1st, we have one more special thing apart from our regular game after the talk. Johnny, would you mind describing it to us for a bit?
Yeah, sure. So like throughout the talk, throughout the whole evening or morning for you guys, just in the YouTube chat, just come up with like a theory that like sounds like it could be right but it's actually wrong, or just like a silly theory with like a great pun in it. We always love that. Just sort of like an April Fool's title or theory of some sort of that. At the end we'll sort of go through them, and then maybe Debarati, you can pick your favorite one or something like that. I'm afraid there's no prizes. There would be prizes in the pub.
See, you've got the master power. That's pretty neat.
Come up with funny ones. I like funny ones.
See, listen, everyone. Let's think of something funny. All right. On that note, we're going to move on to the talk first. If there are any burning questions, as always, please put them either on Slido or in the YouTube chat. Otherwise, we'll let Debarati speak as time goes on, and later she will take on all of your questions at the end of her talk. So without further ado, Debarati, would you mind sharing your screen?
Awesome. Here we go. Share.
Fantastic.
Amazing. Awesome. Let's get this laser party started. Okay, so I'm talking about chasing water on Mars with lasers. As you can see, my little water droplet and my little rover shooting a laser. I clearly spent too much time on this starting slide. But yeah, this is what I'm going to talk about, and let's dive into it. So who am I? I'm Debarati. Hi. I'm a McGill graduate student. I am also a member of NASA's Mars Science Laboratory team. And I use the data from the Curiosity rover to study these squiggly lines, as you can see here. I'm just going to confirm if you can see my cursor. Perfect. Yeah, so I study these squiggly lines. I'll talk to you more about these lines in a little bit. And I get the data from these features that the Curiosity River took. I also study similar features on Earth, and I'm a National Geographic explorer because National Geographic gave me some money to go and do field work to study similar features, which is awesome. So I went to Death Valley, and please ask me all your questions, burning or not. Who do I work with? I work with a lot of fantastic people, some from Los Alamos National Laboratory. So I don't know if Aja knows them. So my immediate collaborator is Dr. Patrick Gazda. We collaborate on the data. He came to field with us, work with the two PIs. The current PI of the ChemCam instrument on the rover is Dr. Nina Lanza, an absolute inspiration. Also Dr. Roger Weens, who was the fantastic PI for the instrument till now. My supervisors at McGill, Dr. Richard Levier and Dr. Kimberla. That's an image of us in field, and we go to like whatever talks, and we have to take pictures with all the NASA logos that we ever see, because never gets old, you know. I have to show that send that to my mom, like, hey, look. Anyway, so what exactly do I do? I study the element boron using the laser instrument on the Curiosity rover to understand past water activity on Mars. So this is a very broad strokes description of what I do. And don't worry, I'll get into the details of this in a little bit. And why did I choose boron? Because we chose boron because it's incredibly water soluble, loves water. So wherever there's warm, neutral to alkaline water, it will get dissolved and it will go where the water goes. So it's a great it's a great marker for where sort of neutral, warm-ish water where Earth-like bacteria thrive could have gone. So here's a picture right below the borate salt of a borate mine in California that we took when we went to field, and you see all these like little veinlets running through. So what may have happened is that there were all these cracks in the rock, and a water body that was full of salts or dissolved stuff kind of went through it and then dried off. So we can't really see the water, but we kind of know what the water conditions could have been, because these veins that trapped all the minerals kind of act like a snapshot of what would have happened. So that's awesome. Also, because not very long ago, that's like 2016, which is 5 years ago now. That's like not very long ago. That we found the first signs of boron on Mars in these lines, in these little veinlets, which are similar cracks on Mars rocks that probably once upon a time got filled with water activity. And scientists think that this happened because groundwater, as an underground water, kind of like pushed into the rocks and infiltrated these cracks and then dried off. So these cracks are filled with the material we know on Earth as gypsum. So if you know about plaster of Paris, that has the mineral gypsum. That's probably where you've commonly heard of it, or if there are geologists in the crowd, you've probably heard of it several times in your mineralogy class. So this is important because it is underground, it's sort of protected from all the harmful UV radiations that are hitting the surface of Mars constantly. So if there was a possibility of any Mars bugs to survive, this is a pretty great place for them to prevent getting burnt down to a crisp by the UV rays. So this research is quite awesome because boron kind of ideally means that there would have been water around 30, 40, 50-ish degrees centigrade and neutral to alkaline range. And also a bonus point is that boron on Earth is known to support the structure of ribonucleic acid. So RNA, or RNA as we know it, RNA is a simple single helix prebiotic structure as you can see on the left side here. And each of the, like, this whole thing is made up of a ribose sugar, which is this pentagon. So what boron does is it kind of attaches to one of these sites and stabilizes it. It stops it from unfurling into an aldehyde, basically. What this can do is this structure can decompose to an aldehyde if there are any chemists in the group. Basically, it can unfurl and then not be useful to this helix anymore. So what we've found is that boric acid can prolong the lifetime of RNA. And that means that there's a potential. Boron kind of shows that there's a possibility of warmish water, neutral, also supports life. And that kind of points towards potential for life. And that potential itself is quite amazing, because it's by itself quite hard to tell what exactly life is. And this is also important to kind of understand where could we possibly find life if we want to send future missions. So let's take a virtual field trip to my field area on Mars. And I've used Google Earth for this, so any of you at home can do this trip yourself. So let's zoom into Gale Crater. That's what my area of study is. So as we keep zooming in, we'll have a couple of pit stops. You see this little ellipse here, that's the landing ellipse. And as we zoom in, you'll start seeing all these names popping up. They're just basically like, you know, name scientists have come up with to kind of identify all the areas. Like we name our streets and, you know, curbs and stuff. That's kind of what happened. And this red line is the Rover Path. It's not updated yet, which is fine. But the rover right now is somewhere around here. It has crossed this little ridge-like feature, and as we go closer and closer, you'll see all these features that almost look like river deltas and, you know, like river channels, like water has moved through these, and you can see these like really beautiful structures over here. So the rover kind of like went up this ridge. We call this ridge the Vera Rubin ridge. Super fascinating because we don't know why it's a ridge. I mean, we know now, like, you know, before when we were looking at it, we didn't. But now that we zoom out, we'll start seeing these alluvial fans, and we'll see the central mound of the Gale Crater. And that's basically where we're kind of aiming to go to understand what formed that and what happened. So let's say goodbye to this. A very quick field trip to Gale Crater and look at it in a more stabilized picture that doesn't give you motion sickness. So this is Gale Crater. It's about 150 kilometers in diameter. It's like roughly the size of Hawaii, I think. This is a landing ellipse to give you a context of what we just saw. And this is the central mound. It's called Mount Sharp. And it's made of sedimentary rock. So it's made of sediments, basically. And sedimentary rock forms when there's a whole bunch of water. And sediments get dumped, and then over time it gets lithified or compacted into rocks. This is about 5 kilometers high. So that means there must have been a lot of water for a long time to form this mountain. So that's kind of what we want to know. Like, and the more layers, different layers of sediments that we have, they're all snapshots of what happened. And when we study these sedimentary layers, we kind of get an idea of what could have possibly been at a warmer and wetter period on Mars. So let's have a even closer look of the path and what my research kind of focused on. So as I mentioned, this is the Rover Path here in red, and you'll see a couple of squares and a couple of circles, and you also see this little ridge that I showed you in the image before. It's called the Vera Rubin ridge, and it's quite interesting because it's standing up against the rest of the topography. So scientists were they were like, why is this happening? And Is the chemistry different? Why is it more resistant to weathering? That's quite an interesting feature. So you see all these squares and the circles. These are all the places where we detected boron. And the boron detection technology is fairly new because we can't measure boron on any other feature rather than these little squiggly white lines, because everywhere else there's so much iron in the rocks of Mars that it interferes with the signal of boron. So we can't really measure it anywhere else. It would be awesome if we could, but right now we can't. So if we zoom in to this little ridge area, which is where I focused my research on for the past year, and published a paper if you guys want to go into the details of what exactly I found and how I found it. So we went up this ridge, and this ridge was so interesting that we actually traversed it twice. We went up, then went down, and then came up again, and then left, because then we have like 2 transects to kind of actually really compare the chemistry of this entire ridge to actually really understand what's going on. So along this ridge too, we found a couple of points which were showing enrichments of boron in them. We also found other water-soluble elements like lithium, and then we sort of tried to compare these water-soluble elements, and we got a trend between boron and lithium that kind of points towards what could have happened when water is evaporating. It kind of started showing that, okay, well, maybe boron is forming a salt while lithium is moving away from it. So that's kind of what I summarized in my work last year. But before we go to any of that, to a summary of what exactly happens, how do I measure the boron on Mars? With lasers, of course, as the title. I mean, it had to come somewhere, right? So here's the Curiosity rover. And this is the head of the Curiosity rover, or it's also known as ChemCam, which is chemistry camera. And ChemCam has this one eye. And this little center point is called LIBS, or it stands for Laser-Induced Breakdown Spectroscopy. And with this LIBS instrument, we blow stuff up on Mars. Just kidding. It's not this big. We do blow stuff on Mars, but the extent of blowing stuff up is not this high. It's actually very small. This is a real picture. I should have been like, oh, April Fools. Anyway, so this is an actual image from this is like a stop motion sort of an image from the soil of Mars, and you can see that this is the radius of the ablation of the Mars lasers, the ChemCam LIBS laser, and this is around 5 millimeters. So the thickness of this beam is around, if you put a couple of your strands of hair together, that's basically the damage it's doing on the rocks of Mars. So what it technically does is it shoots a very high-powered laser onto the surface of rocks or soil. As you can see on the left side here, it shoots a very high-powered laser, and it forms a plasma, which is a fourth state of matter, and it's very high temperature, emits a lot of light, and this light is then captured by a spectrograph or a camera. And this light contains information about what is the chemical composition or the chemical breakdown of the rock, because it contains all kinds of wavelengths. What this plasma does is it like kind of raises the energy levels of this rock sample once it has turned it into a plasma, and once it cools down, whatever wavelengths that are given out are basically the fingerprint of the element, and we kind of get what wavelengths it's giving out based on the wavelength range and the intensity. And the intensity kind of gives us a relative concentration of what element is present. So you can see an example spectrograph of what a spectra of what we might commonly see on Mars. It contains silica, magnesium, calcium, and all sorts of stuff. So we have like 3 ranges where we can measure our data in. So that's kind of how we get the data. It's like we were saying, it's basically numbers, as cool as it sounds. We also get images, like you can see it here. So why is there, getting back to why exactly is there any boron on Mars? Is it a similar cycle compared to Earth, where, you know, there are evaporitic deposits where, you know, a bunch of water is evaporating and enriching boron and lithium? Are Martians just washing their windows with borax? Let's find out. So here I've sort of compiled a bunch of diagrams based on all the work that has been done on Gale Crater, and here's a sort of exaggerated, scale-wise exaggerated representation of Gale Crater. So here's the crater bed, is that what? Yeah, crater base. Here's the central mound, the Mount Sharp, and obviously the dip is not this high, but this is what we kind of assume happened. So the crater probably formed because of an impact, and when the impact happened, it formed all these cracks on the crater base. And then during a wetter, warmer period on Mars, there was rain and a lot of water accumulated on the surface. And this water that was running off of surfaces kind of weathered out a lot of the surrounding rock material and dumped it in this crater. Eventually, we think that this wetter, warmer period started to become drier and all the rain kind of stopped. So the water started to evaporate. In this previous setup, when it was raining, when there was all this water evaporated, water that was kind of pouring into Gale Crater, we also think that these cracks on the base of the crater started getting recharged, started storing all the water. And once this water dried off, it started becoming more briny. If you just like leave some salty water in a container next to the sun, you'll start experiencing that the water is turning more briny, and there are little salt crystals that have started to form in the crust. So that's kind of the process that's happening, and consequentially, the water that is stored in underground is also becoming more briny and storing basically the history that the water is experiencing. So eventually all the water kind of dried off, and the wind came in and sort of scoured through a bunch of stuff. And this is the representation of Vera Rubin Ridge. And we think that there was some later groundwater activity that cemented this area a little harder. That's why it just kind of stayed as this little lumpy ridge. So then what we think, because all the pressure is lifted from this section, all the underground water kind of now injected through the cracks, or sort of formed these cracks through all the weak points, and got injected within the overlying rocks, and then formed all these little veinlets full of these groundwater. Eventually, this water also dried off, leaving behind what we see today. And that kind of, once we study these veins, it gives us basically the last snapshots of liquid water on Mars and gives us an idea of what could have happened. So there's a lot of information that we don't have, and that may be a resultant of many different generations. There may have been a later stage of rainwater, and that could have remobilized some of this material and taken it down here. And it's like, nature of Mars just kind of messed with us, like, haha, you're never going to figure this out. But it's basically trying to be a detective and work your way back into what possibly happened based on these last bits of evidence left by water activity on Mars. So that's cool. That's the kind of data that we get, and we're trying to like sort of build a story. But what we can also do, we don't actually have the technology to send a geologist to Mars yet. The next best thing we can do is kind of study terrestrial analogs. You can see all these images on the top. These are images that we see from the rover. You see these beautiful sedimentary rocks with these lovely veinlets of evaporites running through them. And if you look in the set of pictures below, if I didn't have a camera, if I didn't have a lens cap and a little pen, I bet you would not be able to tell whether this was Mars or Earth. They're fairly similar. And although there's a difference in atmosphere on Earth and Mars, the physical and chemical processes that are overall forming these features are going to be the same. The laws of physics and chemistry are going to be similar on both planets, whether or not, some parameters are going to be different, but they're quite similar. So to get a ground truthing, I also do some terrestrial analog studies. So 2 summers ago, I went to Death Valley to collect these samples that have sulfates and borates. We went to a borate mine, told National Geographic, hey, you should give us some money to go do this. And they were like, okay, fine, here's some money. So that was great. And so we went to Death Valley for around 2.5 weeks, and we saw these beautiful features. I was very surprised that we saw them because that was my first self-planned field work. And we just kind of tried to go to a place where we would see possible presence of sulfates and borates so that we could actually like see boron inside sulfate veins. Fortunately, we did find these veins and took a lot of samples. And I blog about my fieldwork. It's called Finding Mars in Death Valley. On the field notes, it's called National Geographic Field Notes. And it's painfully behind because I got busy with lab work and stuff, but I'll update it. And it has some cool videos about how dusty it gets in Death Valley, and it's just beautiful, and every geologist's dream. So yeah, that's it. Thank you for listening, and shoot me with your questions. I'm gonna stop my share here.
Oh, thank you very, very much, Devarati. Let me real quick switch the view because using 2 screens is not always okay. Great, yeah, we're all back up, so now we can see each other. Great. So once again, thank you very much for an awesome talk. So can you please remind us where we can find your notebooks? Because I think that's very interesting for everyone. We'll put it down in the link on our website as well. But can you please remind us where we can find your fieldwork notebooks?
Let me. The fieldwork link is. Okay, where is that?
I think it was, one but last slide.
Here we go.
Thank you very much. Okay, so it's on the National Geographic. I assume that if we Google National Geographic Field Notes, we can find yours in there, right? Somehow.
Yeah. Once you go to Field Notes, when you go to Nat Geo Field Notes, they'll show you a little search bar of like search expeditions. So if you look for Finding Mars in Death Valley, my sad little blog post with 5 posts right now will show up. I mean, there are many posts with very prolific writers who write a lot about field. I'm just trying to edit a video and put that in. I'm like, it's taking too long, but I'll keep doing it. But there's still some stuff about what we found and some dust. We had a dust storm, and it's there. The video is there, and field prep. I'm doing some lab work now. We're trying to do some theoretical modeling. I'm going to update it, and then you guys can read all the funny stuff that happens in field and in lab, and it's going to be great. Yeah.
That's awesome. No, that's just truly fantastic. Thank you very much.
Right.
We'll definitely, on my part, will definitely check it out, and I do encourage everyone who's watching to do that as well. Maybe you will choose to include a link to this to this YouTube
Ooh,
video
yes,
for
I can
people.
do that.
Yeah, so that
Absolutely.
people got a
Totally do that.
background of why you did that, right?
Yeah, exactly. It's going to be a great explanation, to have that presentation up there.
Awesome.
Awesome. Stop the share now.
Awesome. Thank you very much. So at this point, I would just like to remind everyone that we are still playing the April Fool's game, in which we put our made up favorite theories in the YouTube chat. If you cannot do that in the YouTube chat because you don't have an account and you're just watching just watching our stream, then you can do it on Slido as well. But on that at this point, I will move on to the questions in Slido. If you don't mind taking some of them, the vanity, let me change.
Not at all. Yeah. That's okay. Good question. Also, it's a bit of a mystery to quite a lot of scientists who study craters. So it's actually a crater, and it's not a volcanic crater, as Mars is a dead planet. It doesn't have any geothermal activity. But often what craters do is they form a central mound. So there are a lot of theories about why this happens. When you look at a droplet of water in a larger plate or container of water, and if you watch it in slow motion, I listened to this talk once, and this was a really good explanation someone gave. Was maybe this is what happens when the water falls into this water body, kind of has this rebound. So maybe that could have formed the central mound, but it's not a volcano. It's not pressure from underneath that formed this. It's just I don't know, but yeah, it's because yeah. Good question. We don't know. That's why they sent the lander there to check if there are any Mars quakes. I think we're still kind of waiting to know if that's a thing. But yeah, yeah. No, it's much deader than Earth, and magnetic field wise too. It has remnant wisps of magnetic field, but it's not a beautiful field cover like a spherical field cover like Earth has. So yeah, no, we don't. It's a pretty dead planet that we don't see any tectonic activity on. Landing ellipse is basically, it's like when you throw darts at a dartboard, you have circles, right? So it's like basically an area geologists or engineers mark when they want to send something to land somewhere. So it's basically a target area where you are throwing your dart, a very expensive dart of a rover, and kind of hope that it lands there. And if you notice, these landing circles or ellipses are often on very nice flat areas. Perseverance did a fantastic job at landing safely and not being destroyed to bits. Yeah, so it's a safe-ish terrain, which has good scientific goals, where it can traverse and go up to areas that we're interested in. It was similar for Curiosity rover. So yeah, that's what the landing ellipse is. Absolutely, yes, yeah. That's why it's called when it's like landing, it's called the 7 minutes of terror. Um, yeah, it's really scary because you don't get a lot of like communication during the few last few minutes when it's actually landing, so it's quite risky, and everybody is like on the edge of their seats, and once it lands and gets like the first image or something, everybody's like, oh, this is great, awesome, we got a shitty picture, because the first picture is like dusty. Once like a really an RV weigh something that weighs as much as a truck drops on the dusty surface of Mars, there'll be like a lot of dust. So yeah, it's quite risky. Right, yeah, exactly. Yeah, yeah, exactly. It's like, lots of people are like, oh, my job is on this line. I really need to do a post. People have already like started their postdoc projects, or like their grad topics are on stuff they're gonna do in Jezero. So people are like, I really hope it lands because I want to do my PhD. Yeah, exactly. Yeah. I think, well, it's lost to the atmosphere because, well, I guess Martian atmospheric pressure is not high enough today to keep water liquid, which is why we should be really thankful for the atmosphere that we have on Earth. It is the atmospheric, what we call 1 atm, or atmospheric pressure, is enough to keep water, ice, and all the solids as we know it. But on Mars, that's not the case. It eventually at some point lost the kind of, we think there may have been an atmosphere that was similar to Earth at a very early stage. That's why it helps to kind of study really old craters, example Jezero crater where Perseverance has landed, and also Gale crater, which is like around 3.8 billion years. It's quite old. So at some point, we don't know when it happened, but at some point the atmosphere kind of lost. We didn't have the things required to keep the atmosphere, and then the water probably just evaporated. So, but that doesn't like extend to underground water. We haven't seen any evidence of it. We haven't seen direct evidence of it. We do have liquid and carbon dioxide ice on the poles. Yeah, we do have the ice caps, but uh, we do think that there could have been groundwater that actually extended the window of surface water, which is really exciting because that just means that there was more time for life to kind of still hang around, which is why the groundwater evidences are cool. Yes, there are clouds on Mars. They're actually very beautiful. If you are like, a Mars nerd, which I don't think you are, I mean, yes, please become a Mars nerd. Please, because Twitter, like all the Mars scientists is basically waiting to send all these awesome pictures on Twitter. People say that like, oh, NASA is hiding so much stuff from us. We can't wait to share all this stuff from you with you. Like I think Perseverance shared some pictures, and the team got it, and then they immediately started tweeting it, and they were not supposed to. So everyone had to delete their tweets. So we're like, scientists basically cannot wait to share the images with you. So if you go on Twitter and you just like type Mars clouds, you're gonna. Recently, I remember seeing these beautiful little wispy clouds on Mars. I think this was near Mount Mercure in Gale Crater. So I think it's a Curiosity rover picture of like these beautiful little clouds on Mars, and that's beautiful. Mars has seasons. It has dust devils, and you can, like, with Perseverance, you can hear the wind and the little laser sounds it makes. So yeah, like, if Mars Twitter is great. You get these images all the time. You'll get like Mars panoramas and like all kinds of cool stuff. So to answer your question in short, yes, there are some beautiful clouds on Mars. Yeah, or just Google it. Like, I'm sure NASA has them on Twitter. Is not the main, source for all these images. They're all like probably by NASA scientists who have put them up on NASA, and someone's basically sharing the link. But I follow all these like Mars scientists, and they'll like share the link. I'm like, oh, this is so great. So yeah, Google it first before you go to Twitter, because yeah, do that. Yeah, don't know. On Mars or ever? Okay. Ever. Well, I can give you like two answers. One could be Mars based. So I'm a little biased because I love gypsum on Mars. So everything that's salty and evaporitic, that's my favorite. I'm like, yes, just give it to me. Just shoot that. Just please. Okay. Let's just do that. But in life, I think I once found a geode. I found a little piece of basalt, and it had a little geode which was in the shape of a heart. And I was like, this is my favorite rock ever. And I like tied a little metal wire to it, and I wore it around my neck. I think I still have it. So yeah, that was pretty rad. It had like little it had little quartz crystals and stibnite crystals in it. And I found it when I was in second year of geology. So that was like a big deal. Basalt, I don't care about basalt so much now. But before it was like, oh, basalt, it was great. But yeah, no, I would say that it's my favorite piece of rock that I've ever found. Yeah, just very brittle. Absolutely. No, so the samples that Perseverance is going to collect, they're actually quite different from what Gale Crater has. So Gale Crater doesn't have the technology for sample return right now, only Perseverance does. So Perseverance is basically going to like drill a little like a tube basically like around this size. So it has a little drill. So it's going to like drill it and then cache it that like a later mission will go and like get. So those won't break probably because they're probably sealed in these really nice metallic tubes, and hopefully it'll reach Earth safely. And so far we don't really have evidence of gypsum or any gypsum on Perseverance. I'm hoping we do, because as we see things with the rover, we see more things than we just saw from the orbit. So yeah, I hope we see them. And they are kind of brittle, but I think because of the metal tubes, we'll be fine. Me too. Yes, me too. It's actually, Death Valley is not as deadly as it sounds. In fact, it's thriving. It's so full of life and like really weird life. They have pupfish that like that only live the 2 months of spring. Not even two. I think it's like a month ish. So like it's cool enough that there are little streams and rivulets on these dry lakes, and these pupfish just basically are born and they make babies and then they die because it's just like dries up. And they're called pupfish because they seem very playful, but they're actually reproducing. So the person who saw them, oh, look how playful they are. And it looks like they're playing tag, but they're not. So it's like full of these weird like life things. And they have like these little desert tortoises. And if you pick them, they'll just pee. And that's all their source of water. And they'll just dehydrate and die. So if you ever see a desert turtle, like don't touch it, okay? Just like let it be. It will not be happy if it gets really scared. I don't know what they're doing in a really like harsh condition. It can get really hot. And like if you're going in field, you have to be very careful to drink lots of water, not stay out too long in the sun because it can go up to like 52 degrees centigrade. And it's just hot basically. And like I camped in for like a week and a half and there wasn't any like running water, so it got grimy, but it was fine. I mean, we went to this town called Boron, and we stayed in the motel Boron motel, and that had a shower and that was great. So you won't die. It's great. It's awesome. Like, yeah, it's not that hard. People go, yeah, no, don't do that. Yeah, they'll die sadly. Yeah. Very good question. It was all trial and error, actually. So I had the same question. I didn't know whether what I'm gonna get is exactly what I'm gonna get. It was a problem because not a lot of work had been done in that area because borates are less commercially important than stuff like gold or other precious metals. And people didn't really like care about that research enough to kind of really have a detailed mapping of some sort. So it was a bit of a reconnaissance field trip, but then I think I got lucky that areas where I kind of just made a logical assumption that if there's a borate mine here and if there are some there are like old areas that have said that, okay, there are some gypsum outcrops here. So I kind of like marked them, drove up to those areas, and then got really excited that I'm seeing these veins. So it was a trial and error method. Some areas we didn't find anything, some areas we did. So I marked a lot of potential areas, talked to some people. Some people had already like gone to Death Valley and like these are some good areas. You can go collect these things. I also had to get a permit. So I talked to the people in the park saying that, what do you think would be a good area, where I can go and take samples from. So having a whole range of possibilities where I could get some samples was good to actually get some samples back home. So yeah.
Right. Awesome. Thank you very much. I think that was the last question. And I love how your first response to how did you know? Well, trial and error. I think it beautifully illustrates what science really is on many occasions. Especially experimental science, the one that teaches us new things about the world. So I think that was a very valuable input. Thank you very much. At this point, we can move on to a very quick game, which you have sort of initiated by showing us both pictures of Mars and Earth that looked very similar, especially showing the rock formations. The only giveaway being, I don't know, pens or or hammers. So we can move on to that game, and at that point, Chloe, would you mind taking over?
Yes, of course. So yeah, it fits in really, really well with the talk. Because basically we're going to show you some pictures and you have to guess whether it's Earth or Mars. And I don't actually know the answers. Asha's got all the answers, so I'm playing it blind as well. So if you go to the Slido, it's on there. And Asha, if you want to show the first picture, please.
Absolutely. Let me do that. Also, let's not forget that we have a little bit of a delay between us and the audience. It's tiny, yet it's enough to cause a little bit of confusion. So right now we've got the first picture up, and it looks like a bird's eye view on whatever we're looking at. Colors definitely reddish. Reddish bluish. And it would be interesting to know what people think. And
sure.
I've got some answers coming in. Let the audience give a couple of minutes. Actually, at this point, I also wanted to mention that this game was shown to the flight engineer who became a meme after Curiosity Mars landing because of his mohawk hairstyle, and he was given the exact same game and scored 9 out of 13. So the challenge is for you guys to beat Bobak in this game. All right, I think we can reveal the answer. What do you think, Chloe?
Oh, I don't know. I think it's Earth, but I feel like I'm going to be wrong.
Wow, cool. So let me reveal the answer. And yes, it is indeed Earth. And in fact, do you know what formation that is?
No, I don't. Do you?
I do. I actually did. That was the only one I recognized. That's the Grand Canyon.
Oh, yes, of course. For sure.
That's the only reason being I stared at this picture for way too long. So I immediately knew the shape. But that was the only one I got immediately. Right. Yeah. Oh, actually. So we had split votes between Earth and Mars, and Earth won ever so slightly. So yeah, people, first trick question down. Okay, I've launched the second one now. I'm going to change the present.
Yeah, this looks really interesting, this one.
You know what it reminds me of? A little bit of the barnacles that...
Yeah, I was going to say something like ocean-like at the bottom of the seabed. Or...
I was going to say something a lot less informed and say crop circles, but I think that's wrong as well.
Crop circles. Yeah, tricky one.
Actually, the Vanity, do you know this picture? And if you don't know, what would be your guess?
I think I've actually seen this on Zooniverse. Have you guys heard of Zooniverse?
Yeah. Mm-hmm.
I think it's Mars.
I was going to say Mars just by how cool it looked.
Yeah, fair. And it doesn't look like a close-up, right? It doesn't look like a microscope picture. It's more like a top-down view.
Yeah.
Right, so let's see what the audience thinks. And the audience thinks, overwhelmingly, that this is Earth. And excuse me, everyone, this is Mars. So yeah, you guys are correct. I'm sorry, Johnny, that these were not crop circles. I do apologize for.
What are you gonna do? We'll find them eventually.
Yeah.
And the third picture, that's pretty nice. It just looks like a sorry to be colloquial, but just a picture of dirt. I mean, soil.
Yeah. Mm-hmm. Yeah, it looks very dusty and almost desert. Not desert-like because it looks more rocky than sandy.
Yeah.
But it is very red.
It is. So, although it very much reminds me of the landscape we have around here in New Mexico. If you go on a hike deep into the desert, well, like deep enough, let's say, into the desert area, that's essentially what you're walking on, maybe with an addition of, of plants. So, the audience, if I can just switch, I'm trying to be smooth here, you know, with these screens. Let's see what the audience thinks, and the answer is, overwhelmingly Mars. So definitely not New Mexico, although there are some people who think like me. That's good to know that I'm not the only one. And the true answer Let's reveal the true answer with the slide. It is. Yes. Oh, it's actually Everest Panorama. Debarati. Is Everest anywhere close to where you've taken your boron samples from?
Did you say Everest?
Yeah.
No?
That's what the internet said it was.
Oh, no, I haven't heard of that.
Maybe I misspelled it, but I'm sure it was called the Everest Panorama, or maybe it's just a nickname for the picture. It might as well be, not the location.
Yeah, that could be it.
Okay, fair point. Fair point. I do apologize for the misleading statement. Oh, we've got another picture of dirt. Sorry. Well, but that one is different, or is it the same?
Well, it's got a bit more different colours in it, this one. Yeah.
But rocks look very similar, though. Like
Yeah.
Also, I would call it armchair geology. Armchair geology is probably not the best way to do geology.
Yeah. Mm-hmm.
The Barati can probably testify to that you need to actually touch and sometimes lick the rocks to know what they are.
Yeah, we definitely need to lick them.
But isn't it true that you sometimes lick the rock to taste whether it's salty or not and things like that? Or is that not?
Actually, that's one of the ID features for slate or chalk. And it's like it tastes chalky, which is funny because first year geologists always, pick up random stuff and taste them that they're not supposed to. But I mean, thankfully, there's not a lot of poisonous stuff out there. Mostly just dry animal poop. That's the worst they can do. Yeah, armchair geology is not fun, especially like when you have friends like, "Hey, what's this rock? I don't know. Looks like a rock."
Sorry, just a rock. So speaking of just rocks, Chloe, do you think we should reveal the answer? I'll tell you what the audience thinks. Yeah?
I'm going to go Earth for this one.
Just because the previous one was Mars?
Well, also, the picture's very high quality.
Yeah, fair point. Fair point.
So
So that was probably the dead giveaway. So yeah, it's actually Earth. And funnily enough, the audience thought it was Mars again.
Ah.
So, and
maybe
this
it
part...
was the colour.
Yeah, maybe it was the color. And actually was the picture was taken in Hawaii. And yeah, I think as a spoken like a true astronomer, high resolution means local.
Yeah.
Right, we've got the next picture up, and let me switch that real quick. Ooh, that's a change.
Yeah, that one's really cool.
Again, giving me underwater vibes.
Yeah, definitely.
Like the ripples that waves.
Yeah.
That waves create.
Yeah.
Although, where would you see that exposed like this? Or maybe it is an underwater picture and it's been done black and white.
Yeah. Or somewhere where the tide has gone out, but yeah.
Yeah, they go at very... It looks like it's just going all over the place. Like directions are weird.
It's crazy.
Okay, so let me check what the audience thinks. And oh my god, everyone agrees this is Earth. So Chloe, what's your take?
I was gonna go Mars because
Let's
it's so
see.
crazy.
And ta-da! It's Mars. It's actually
we're
Mars.
good at this.
And I am okay. I was surprised seeing this when I made the game because it really did look like, I don't know, beach patterns. Yeah, I'm doing this game very slow. Sorry. Okay. Oh, number 6. I think we may have talked about this. Looks like a giant eyeball.
Yeah, it's really interesting, that one. But it looks sort of snowy.
Oh yeah, it looks sort of snowy.
But yeah, I think we did talk about it. So
yeah, so I think it shouldn't take the audience too long to make their choices, and indeed they didn't take too long. So, someone just changed their answer. Sneaky you. 100% Mars on the audience side, and yes, indeed, that is true, and that was actually, if I'm pronouncing it correctly, Pavonismon's volcano. I'm probably not pronouncing it correctly. Please excuse me. Ooh, the picture 7. Picture 7. Let me pull it up. Picture 7. Oh, that's a lovely panorama. And there is atmosphere in there.
Looks very Mars-like to me.
Yeah. Yeah, it looks
could
like
be
a scene.
trick.
Yep, it could be a trick, just like all of the April Fools. But it does look essentially like a scene taken from what's the name? The Martian. I forgot the name of the movie about Mars. A book actually, but yeah. So the audience has spoken, and it has spoken, wow, 67% Earth, 33% Mars. People are thinking that I'm trying to trick them, I think.
I mean, we do have a track record with Panel Planet and several. It's both answers in the previous months. Maybe people are queuing up. They're getting wise to our tricks.
Yeah.
Fair. So Chloe, you said Mars, right?
Yeah.
And you were correct, and it's actually Gale Crater.
Oh, look at that.
Yep, and in fact, this is a picture that Bobak took himself. At least that's what he said when he saw this picture, when he was presented with the game. He was like, "Oh, I took that picture." So that's that must feel pretty neat.
So we must have got that one right then.
Yeah, at least. So if there's anything you guys can be sure of in this game, this one picture is correct. We labeled it correctly. Oh, I love number 8.
Yeah, it's a really nice picture, isn't it?
See, but it's not very high resolution, is it?
No, but it looks like it's taken. Well, it could either be taken from really far away or it's really close.
Oh, like a picture of a rock, as opposed to.
But I think it's a faraway picture.
A faraway picture. And if it's a faraway picture, then what do you think it shows? I'm curious.
I'm stumped. What about you?
Well, so I know the answer, and I also know the subject because I like looking at pictures on the astronomy picture of the day. So I'm a bit of an iPod geek. But had I not known what it was, had I not seen it before, my guess would have been Mars, just because of the veins. Regardless of what the answer is, veins to me look like Mars. But what is in reality, we can actually reveal it since the audience has spoken, and it's actually Earth. This is the meteor crater in Arizona.
Oh wow.
Yeah. So, the answers were split 50-50, Earth and Mars. I'm not surprised, just because, as I've said, had I not known that it was the Arizona crater, then it would have been easily Mars.
Yeah, I think I was leaning towards Mars on that one.
Oh, that one is so pretty, number 9.
Yeah.
See, so that's something I would say is straight out of a geology textbook.
Yes.
Yeah, like when you've got water flowing down the glacier and it creates, I can't remember what they're called. The Bharati, you're probably going to help me out on this one. These flooding cones that are created, cones of sand that water.
Alluvial fans?
What's the name again?
Alluvial fans?
Yes, exactly. I think that's what the picture depicts. Exactly, like cone-like structures that go into these narrow ridges.
Yeah, there's definitely been some fluid motion to cause that.
So the audience says overwhelmingly that this is Earth. What would be your call?
I don't know. Probably Earth for that one.
All right, let's reveal the answer. Nope, It's Mars.
Wow.
It's actually Terra Sirenum. I assume that's the mermaid land. Is that a correct translation? I'm probably making this up now. But but yeah, it is definitely Mars, although it looks like alluvial fans. Oh, number 10. That's a mess. Looks like a rock again.
Mm-hmm.
Okay, now that I'm seeing more of them, I think it's more respectable to get 9 out of 13.
Yeah.
Yeah. Yeah, at first I thought, oh my god, he got far wrong and he works on the Mars rover mission.
Yeah, my mind is tricking me now.
Yeah, the deeper you go. Well, for this one, I've stared at this one the longest out of all of the images when I created it, just because it was confusing to me. And now I know what's the dead giveaway, I think. So the audience says Earth 80%, Mars 20%. What would be your call, Chloe?
I'm going to say Earth because I'm not sure whether those are lakes. That's from high up and they're lakes.
Yep, and these are lakes in the Yosemite National Park. And I think the dead giveaway would be, but then again, I might be wrong. So Bharati, I think I need your opinion on this. When you look at a rock under a microscope, when you see different intrusions of minerals, they will have a hard border, right? They wouldn't be smoothly blending into the matrix, right?
I mean, they can sometimes if they're smeared.
Okay, in that case, my argument is invalid because I thought that the lakes, they have these shallow shores, so they look like they're blending. And I thought, okay, that must be the giveaway that this is a lake and not a mineral. But if you say that they can be blendy, then in that case, it doesn't work.
But your logic is more applicable than special cases. That only happens in special cases, because it could just be like mix of matrix and there aren't any solid boundaries. But that happens quite often, that there are solid boundaries. So that was a good logic there.
Oh, thanks. Score on logic. Right. At that point, Chloe, we've moved to picture number 11. At least that's what the audience sees now. Yep. And it's gray. As in, oh my god, what a description of an image. It's gray. What kind of car do you ride? Wait. I mean, sorry. Not so funny. And oh wow, the audience has already made their decision. Jesus, you guys are much faster than I think.
Yeah, I think this one is Mars for me.
Mars? Okay.
Yeah.
And it's actually Earth. Ta-da! It's Antarctica.
Yeah.
I mean, it's just because it was black and white.
Yeah, and the low resolution as well.
Yeah, fair point. Fair point. I think we shouldn't judge on resolution anymore, because the next picture is, I don't know, is it high res or, yeah, I think it's very high res, but also it has weird colors. Number 12.
Yeah. I don't know what that one is.
Also, what are these stripes? Like,
Yeah, they sort of look like shadows, but shadows of what?
yeah. Yeah.
Looks more like a painting than like
Yeah.
a picture. It's so cool.
I think the AOT team that made it could have sneaked in a pancake or planet type question now. No, but seriously though, it does look like a painting. I'm not sure what these stripes are, and the audience said that it was mostly Earth. What would be your take, Chloe?
I'm gonna go Mars.
Because?
Just because it's so cool. Like, why not?
And yes, you were right. It's a cool picture from Mars. So we've got the final one, and I think the final one is a good treat for the eye because it's a very pretty image. It's all white, essentially, but has a lot of texture in it, and I really like this image. Out of all of them, this one is just visually very, very pleasing. although, as we know, we shouldn't be distracted by the color because we know that we know from today's talk that we do have actual ice caps on the poles, or ice accumulations of ice on the poles.
Yeah.
So white is probably should not distract us from the subject of the.
I think I'm leaning towards Earth on this one.
Let's reveal the answer. So the audience says, audience says 100% Earth. And everyone was correct, actually. And this is a picture taken of Greenland, taken from the ISS. So that's a lovely image. And on that note, we can end the game. So for everyone who played, please count your votes. If you get more than 9 or 9 and above, that you're doing great. I feel like
I'd just like to self-promote and say that I got 9, so I'm pretty happy with that.
Oh, wow.
Well done, Johnny.
Nice.
I've learned some geology apparently in the last 2 years.
Oh, wait. Yeah. Yeah, that's a head start. It doesn't count. All right. So unfortunately, not many people joined a total of 2 people joined our April Fool's game. And to be fair, I feel like not everybody likes being put on the spot on a live stream, so that might be the case. But I started us off saying, so the Parati, you've got a choice of 2 theories. So I've started us off with alien civilizations building the pyramids in Giza. I think that's a very valid theory. Just because of the way they are aligned, right? With the Orion belt, I think.
Totes.
Yeah, that's totally solid. And the next theory from Plato Bob is considering our YouTube channel, donut-shaped Earth fits the bill. So I think that's a reference to a previous video that was posted in the Science Week where Chloe actually taught us how to bake galaxy donuts. So I think donut-shaped Earth comes from
Self-promotion.
I'm definitely doing that this weekend, 100%.
Yeah. They're really tasty as well.
It looks so good.
So we do have pyramids in Giza and donut-shaped Earth. So the question is, what do you think? Which one fits your fancy? Suits your fancy?
Okay, to be fair to the process of the game, I think I'll judge it based on creative input and also my bias for life outside this planet. So I'm gonna go with aliens building pyramids in Giza.
Nice.
Because yeah, I mean, Donut Earth is pretty great, but aliens building stuff, that's basically like the premise of X-Files, right? So
Yep.
Yeah.
And there are actually documentaries.
yeah, all the people being like, oh, I got abducted by the aliens.
I mean, I'm relatively close to Roswell, the capital of alien abductions.
Nice.
I think your feed might get cut out all of a sudden. Someone's watching, and it's just.
She actually thought that you were serious.
Oh no, the government's coming after you, Asha.
Oh yeah, thank you. I'm too close. But actually, okay. So Plato says that donut-shaped Earth is actually a thing, and we should Google it. And the moon goes through the hole back and forth. That's why.
Oh, actually, that's actually also pretty cool, but still kind of biased towards aliens building the stuff.
That does sound like a cool paper though for next year's April Fools. So like, there's a big thing in astronomy where people post like April
so many
papers,
today.
like proper like explanation of papers. My favorite one last year was the real habitable zone, which is where you could find planets to make that has all the components of a gin and tonic. That was a good definition for the habitable zone. So maybe we can get someone to work on the black hole and the
Donut.
Donut hole.
Donut hole Earth, the moon going through that.
I'll
Can't
definitely
wait to
make
see
a graphic for it. Yeah, we can totally post it next year.
Yeah. Today
right.
there was also a paper on Jaffa cake to decide if it's a biscuit or cake. So very
Ooh.
important
I saw that
question.
one as well.
There's now a paper studying it, and the conclusion was that it was a cake. So if you want to check it
That's
out.
a very, very good decision. It's in my top 3 biscuits, so
But it's now a cake.
Yeah, I
Wow.
have to rethink my life now.
So now that we've learned all these groundbreaking paper-worthy publications, paper-worthy research. Sorry. On that note, I would like to summarize our evening with a fantastic talk. Thank you very much, Bharati, for sharing both all your knowledge on Mars, but also the personal experience of Death Valley. We'll definitely check out your journal or blog.
Thanks.
Sorry, that's blog, not journal. And I think we've had fun with the game, although it was quite long, but also very tricky. And me personally, I've been tricked quite a lot when I prepared that. So I feel like it was great. I hope you guys liked it, and we shall see you next month for another Astronomy on Tap. And in the meantime, stay tuned on our Facebook page for updates, useful links to, for example, the Bharati's research, and hopefully coming soon. I keep on saying that, but hopefully coming soon, just the talk cutouts, so that you don't have to scroll through the entire meeting, but just get right to the gist. All right. On that note, we can now say goodbye. So,
Bye. Thanks for having me.
Bye.